Welcome to our journey into one of the most daring and ambitious space missions ever attempted, NASA's Parker Solar Probe. This spacecraft is traveling closer to the Sun than any spacecraft before it, diving into the heart of our solar system to answer questions that have puzzled scientists for decades.
Launched on August 12, 2018 from Cape Canaveral, Florida, the Parker Solar Probe is named after the legendary physicist Dr. Eugene Parker, who first theorized the existence of solar wind. It's the first NASA mission named after a living person. But why send a spacecraft so dangerously close to the Sun? The answer lies in the mysteries of solar physics. Scientists want to understand why the Sun's outer atmosphere, called the corona, is millions of degrees hotter than its surface. They also want to know what drives the solar wind, a stream of charged particles that constantly flows from the Sun and affects space weather around Earth. The Parker Solar Probe is designed to tackle three main science objectives. Number 1. Trace the flow of energy that heats and accelerates the solar corona and solar wind. Number 2. Determine the structure and dynamics of the Sun's magnetic fields at the source of the solar wind. Number 3. Explore how energetic particles are transported and accelerated near the Sun. To achieve these goals, the probe must get incredibly close to the Sun, eventually reaching within 3.83 million miles of the solar surface. That's about 7 times closer than any spacecraft has ever gone. Getting this close to the Sun is no easy task. The spacecraft has to endure extreme heat and radiation. To survive, the Parker Solar Probe is equipped with a cutting-edge thermal protection system, or heat shield, made of reinforced carbon-carbon composite. This shield can withstand temperatures of over 2,500 degrees Fahrenheit, while keeping the instruments behind it at room temperature. The probe also uses a sophisticated autonomous guidance system, because it can't rely on real-time instructions from Earth. It's too far away. The system keeps the shield pointed at the Sun at all times, ensuring the spacecraft doesn't overheat.
Reaching the Sun isn't just a matter of flying toward it. In fact, getting close to the Sun is one of the hardest things to do in space. Earth orbits the Sun at nearly 67,000 miles per hour, so the probe had to use a powerful rocket, the Delta IV Heavy, and perform a series of gravity-assist maneuvers using Venus to gradually reduce its orbital speed and bring it closer to the Sun. The Parker Solar Probe will make 7 flybys of Venus over its 7-year mission. Each pass brings it closer to the Sun and allows it to sample new regions of the solar atmosphere.
The spacecraft carries 4 main instrument suites: fields, measures electric and magnetic fields, radio waves, and plasma waves; WISP, a wide-field camera system that captures images of the solar corona and solar wind; SWEEP, analyzes particles in the solar wind, including electrons, protons, and helium ions; ISO measures high-energy particles ejected from the Sun, like those from solar flares and coronal mass ejections. Together, these instruments provide a 360-degree view of the solar environment. Even in its early flybys, Parker has delivered groundbreaking data. In 2019, it detected magnetic switchbacks, sudden reversals in the Sun's magnetic field direction. These strange patterns may help explain how energy flows through the corona and into space. It has also helped scientists map the origins of the solar wind, revealing that the slow solar wind seems to come from coronal holes near the Sun's equator.
These insights are helping researchers better understand space weather, which can disrupt satellites, GPS systems, and even power grids on Earth.
As of now, Parker's solar probe continues its journey, inching ever closer to the Sun with each orbit. By 2025, it will make its final closest approach at just 3.83 million miles from the surface, flying through the Sun's corona at speeds of over 430,000 miles per hour. This mission is not just a triumph of engineering, but a huge leap in human understanding of our nearest star. The data it gathers could shape how we explore and live in space for decades to come.
Thanks for joining us on this incredible journey through one of the most ambitious space missions in history. If you enjoyed this video, make sure to like, subscribe, and stay tuned for more amazing space science content.